learn the three types of learning. What are they? Supervised, unsupervised, and reinforced learning. Okay. Today we'll be learning about some four models. So these models and the learning techniques are most important. Okay. So this will be repeatedly asked in the semester exams. So, so kindly study the different types of learning models, and also uh, so this thing and the four different types of models, there are four different types of models, and study those models too. So these are the very important questions to study with examples, since for MCQ for the first internals it will be asked the based on the examples. Okay. So here what is meant by a model? So we are repeatedly saying about model in machine learning. So what is it model is? So model, from the central concept in machine learning, is what is being learned from the data, what we are learning from the data. So in order to solve the given task. Okay. So that is the model. So we are creating something from the extract which is already present. Okay. For example, we have the data set here. With data set, it will have a certain number of rows and columns. So we have a data set here, and from that we optimize it in sense, in the lab we do the first experiment, right? We do pre-process. So here we optimize it using some metrics. So we have some metrics such as the accuracy, and also we do some pre-processing techniques, cleansing and removing the outliers. Okay, that are the optimization metric, and some constraints we have. That is the time and cost within this period of time, within 1 hour, how the model is running, how the model is training. Okay, so what is the cost of running the model? How much CPU utilization resources it is taking, consuming? Okay, that is the cost. Cost doesn't means it deals with rupees, but it is something, how much the CPU utilization, RAM access, and how much storage space it is taking. Okay, so these are the constraints. So we have data set, optimization metrics, like and the outlier detection, something that is the optimization metric, and we also have some constraints. So from this we develop something called as the automated machine learning program, and from that the model will be evolved. Okay, so here the task that machine learning aims to or classify, we'll classify it, we'll regression in sense, the group analysis we do, clustering. Based on that analysis, we cluster them into particular groups, and the association discovery. So how one is related to other. For example, we are finding something for protein and disease detection. Okay, so from that, we'll see the side effects too. What are the side effects that is causing the disease and everything? Okay, so that is the association discovery, and the models are the output of the algorithms applied to the data set. Okay, so the model describes data that is observed in the system. Example, the output, what we get the output, no, that is the model. So this is the machine learning. This is the machine learning model, and here it is used to the machine learning is about using data to train a model, and we So here, this is the machine learning is about using the data to train a model. And here we split the data set into the training data set and the testing data set. So from the training data set, we obtain the training model. That is the using training data to train the model. We have some entries to train the model, and using test data, we test the model, and the output will be some of the metrics, which is the accuracy. Okay. So here accuracy alone is not needed. We check the precision, recall, sensitivity, specificity, and the metrics, or six metrics are there. So we'll check of the matrices how efficient our algorithm is all about. Okay. So the three ways of machine learning models are geometric, logistic, and probabilistic. Okay. So here these models are applied to new data sets that will help to learn the new behavior and also predict them. Okay. So we will be learning about this geometric, logical, and probabilistic models. First is the geometric model. So it is all about lines, planes, and distance. Okay. So it is a set of all possible instances, that is the instance space. Okay. So whatever the probability of getting the out model, it will be represented in lines, that is using two axes, that is x and y axis. It can also be extended by planes, and also we can calculate the distance between two different data sets. Okay, data points. And here it is easy to visualize, and also it could be described as a points in two dimension, that is x and y axis, or a three-dimensional space, that is planes x, y, z. Okay. So what are the types of geometrical model is linear model and also the distance based model. So for distance based model, we'll be calculating the Euclidean distance. Okay. So here, for example, consider this linear model, and the red color things are the data points which is represented. Okay. So it is 1,6 and 2,5, 3,7, and also 4,10. Okay. So they are the relatively simple. In this case, the function is represented as a linear combination of inputs. So what we do is we draw a f of x, that is the distance. Okay. So the formula for representing the linear line is f of x is equal to mx plus c. So here c represents the intercept and m represents the slope. The slope, or where it is getting slope. So we'll be solving some problems in these linear models, and also geometrical models, and also probabilistic model. Okay, they have a very low variance and something called as the variance and bias is there. Okay, so they have low variance and also the high bias. So how will we calculate this? So the support vector machines mainly make use of these geometrical models. For example, consider this is one data point, the green color thing, which is represented. It is a data point, and here this blue color thing is represented is another data set. Okay, so here the last maximum value of the first data set and the first value of the this data set is calculated, and the distance between them are calculated. Okay, so this distance we want to calculate, and these are mentioned as the support vectors. So about these support vectors we'll be learning in the detail in the module 3. Okay. And here the distance based model, it is a second class of geometrical model, and here we make use of Euclidean distance, Minkowski, Manhattan, and Mahalan-Boles. Okay, so here Euclidean distance and Manhattan distance we'll be learning about it, and many problems will come based on these two distance calculation models. Okay, so this is a formula for Manhattan and the Euclidean distance. So that is a1 minus, we'll be solving these problems in the second module. Okay, so just overview will be given in the first module, and the detailed about every models will be given in the second module and third module respectively. Okay, so distance is applied through the concept of neighbors and exemplars. We'll be studying about all these in the second module. So here it will be the centroid and medoids. We will learn how to find it, and also the k-means clustering algorithm we'll be learning in the second module, and logic models and tree models. Here it is a logic expressions to divide the instance space into the segments, and hence construct a grouping model. So we'll use the grouping clustering algorithm here. So it is an expression which will return a Boolean value, that is it can be either a true or a false value. Okay, so for the here we'll be constructing the rule-based and decision-based model. This is a fourth module. Okay, here about this we'll be learning there, and also tree models also we'll be learning in fifth module in detail. And what is the concept learning? This will be learning in the sixth module. That is the probabilistic models. These modules, these are just study what are the different types of models with example. Just study for this MCQ. And for when you learn come for end semester, you will be learning about these models in details in the respective models. Okay, so this is all about three different types of models: geometric, probabilistic, and also the logistic models, linear model. Okay, so these three models you by hearted because it will be asked in 7-mark question in end semester. Okay, I'll post this in the class, and this is all about today's class.